All right, so we're going to do the same thing for inverse cosine, which again you can say is arc cosine. And just like with sine, you can see right up here what you need to know about it. So let's talk for just a second about cosine. A cosine wave. So let's talk about the domain of cosine. I think this makes it easy if you think about like cosine. The domain is negative infinity to infinity, right? Because it goes on and on and on and on and on and on. But the range, let me put a D right here so we know that this is domain. The range of cosine goes from 1 to, all right, the range of cosine goes from -1 to 1, which means for arc sine, those two things would be reversed. But, so the domain of cosine is going to be -1 to 1. But we have to restrict this because we want it to be a function, and it would fail the vertical line test if we didn't restrict it, which is where this comes from right here. That's where this restriction comes from. They restrict it to that so that it doesn't fail the vertical line test, so that it is a function. So this is our domain and this is our range. So that can kind of help us a little bit when we're looking at these. All right, so if we're just doing this in our head, we can ask ourselves, where is cosine 1? Cosine is the x value. Cosine is 1 at 0. So the answer to this one is 0. And it's actually an answer. That's the answer. 0 degrees or 0 radians. And then on this one, I can ask myself, where is cosine -√2 over 2? All right, well, √2 over 2, those are always the 45-degree angles or the pi over 4s. But I need it where my x value is negative. And at pi over 4 in quadrant 1, right here, it's positive. So I need the one that's over here. So if this is pi over 4, this would be 4 pi over 4. That means this right here has to be 3 pi over 4. So that is my answer. And you can put it in your calculator just like we did inverse or arc sine, and you'll get a decimal answer of these same things. So there you go. That's it.